All right, this is Chapter 1, Lesson 4 for Slytherin on ratio tables. So today we're going to be talking about ratio tables. So the first thing that I want to look at is where it says equivalent ratios. It says the quantities in the opening activity can be organized into a table. This table is called a blank blank because the columns are filled with pairs of numbers that have the same ratio. In those two blanks, you're going to write ratio table. Ratio table. Zoom in a little bit more to make it a little bit easier to see. Okay. Then on the bottom, blank blank express the same relationship between quantities. So in those two blanks, you're going to write equivalent ratios. Equivalent ratios. Okay. So equivalent ratios express the same relationship between quantities. Okay. So we can see from the example they give us, soda and juice, 1 soda to 3 juices, 2 sodas to 6 juices, 3 sodas to 9 juices. So the ratios 1/3, 2/6, and 3/9 are equivalent, which means they're the same. So if I simplify 2/6 and 3/9, I still get 1/3, since each simplifies to the ratio of 1/3. So let's go ahead and look at two of the examples first. So we're going to look at the first one, example 1. To make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? So I can use a ratio table. Since 1 times 5 equals 5, multiply each quantity by 5. So here's my ratio table. I have drops of yellow. I have 6 drops of yellow. Okay, that makes 1 cup of icing. And then I have 5 cups of icing, and I want to know what goes in the blank. Well, 1 times 5 gives me 5. Whatever I do to this, I have to do the top as well. 6 times 5 gives me 30. So I can add 30 drops of yellow food coloring to 5 cups of icing, and I'll get the same shade that I got in my original. All right, number 2 says, in a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. If he ate at a constant rate, remember constant means the same, determine about how many hot dogs he ate every 2 minutes. So I'm going to divide each quantity by 1 or more common factors until you reach the quantity of 2 minutes. So I have 66 and 12, so here's my table. I can divide them both by 2. 66 divided by 2 gives me 33, and 12 divided by 2 gives me 6. Okay, but I want to know for 2 minutes, that's 6 minutes, so I divide them by 3. 33 divided by 3 gives me 11, and 6 divided by 3 gives me 2. So he ate about 11 hot dogs every 2 minutes. So that's the first way you can solve with ratio tables. The next way you can do it is actually by scaling. So use scaling. So multiplying or dividing two related quantities by the same number is called blank. In that blank, you're going to write scaling. Okay. Sometimes you may need to scale back and then scale forward to find an equivalent ratio. So let's take a look at some examples where we use scaling. All right, number 3 says cans of corn are on sale at 10 for $4. Find the cost of 15 cans. There is no whole number by which you can divide 10 to get 15. So I scale back to 5 and then I scale forward to get 15, okay? So we can see that here. I divided by 2. 10 divided by 2 gives me 5. 4 divided by 2 gives me 2. Okay? Excuse me. Okay? But then I still want to get to 15, so 5 times 3 gives me 15. 2 times 3 gives me 6. So 15 cans of corn would cost $6. Okay, so I had to divide, I had to scale backwards, and then I had to multiply. I had to scale forwards to get the answer. Okay? All right, let's look at 4. Okay. Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. So we started with 14 hours to mow 8 lawns. Okay? So that's my first 2 numbers in my ratio table. At this rate, how many lawns could he mow in 49 hours? Okay. Is there a whole number by which you can multiply 14 to get 49? No. So I'm going to scale back to 7 and then scale forward to 49. Okay? Because I know I can divide 14 by 2 to get 7, and then 7 times 7 will give me 49. So I scale backwards first. 14 divided by 2 gives me 7. 8 divided by 2 gives me 4. Okay? Then I multiply. 7 times 7 gives me the 49, which is what I need. 4 times 7 gives me 28. So Joe can mow 28 lawns in 49 hours. All right, now there are a couple of try it problems. Okay, you've got 3 try it problems. So go ahead, try them out, pause the video, and when you are done, come back and we will do them together. All right, so the first one we're going to look at is A. A patient receives 1 liter of IV fluids every 8 hours. So you can see over here on my table, 1 to 8. IV fluids, 8 hours. At that rate, find how many hours it will take to receive 4 liters of IV fluids. Okay, so what did I do to get from 1 to 4? Well, from here, I had to multiply by 4. So since I had to do that, I have to do it down here too. Multiply 8 times 4. Well, 8 times 4 gives me 32. So it will take 32 hours for 4 liters. Okay, 32 hours for 4 liters. All right, letter B. To make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. So 12 cups of sugar, 16 cups of cranberries. Find the amount of sugar needed for 4 cups of cranberries. So what can I divide 16 and 12 both by? Well, I can divide them both by 2. So 12 divided by 2. Actually, I'm going to come over here to my workstation. Okay, so it's a little bit easier to see. Okay, so here's my table, right? Here's sugar, cups, cranberries. I have 12 to 16, okay? So I can divide both 12 and 16 by 2. So when I do that, divide by 2, divide by 2. 12 divided by 2 gives me 6. 16 divided by 2 gives me 8. But I want to get to 4, okay? Well, I can divide 6 and 8 again by 2. Divide by 2. Divide by 2. 6 divided by 2 gives me 3. 8 divided by 2 gives me 4. So my answer for B, for 4 cups of cranberries, I will need 3 cups of sugar. Okay. So for 4 cups of cranberries, you need 3 cups of sugar. All right. Now let's look at letter C. Okay. Letter C says a child's height measures 105 centimeters. Estimate her height in inches. Okay. So I'm going to go over here back here to my workstation. Okay. So I have height in centimeters over height in inches. We said 25 centimeters to 10 inches, and I want to get to 105, right? So I know 105, can't see that, I'm sorry. Okay, I know 105. I can do by 5s, right? Because I have a 5 here on the end. 25 I can also take down to 5. So I'm going to have to scale back to 5 and then scale up. So 25 divided by 5 gives me 5. So I do this 10 divided by 5, which gives me 2. Okay. Then I have to figure out 5 times what gives me 105. Okay. So 21 gives me 105. So I can multiply by 21 here, by 21 here. 2 times 21 gives me 42. So a child's height, her estimated height in inches, is going to be 42 inches. So about 42 inches. Okay, and that is the end of lesson 4.